Dear participants, today we shall be discussing about the solid waste management and its linkages with the climate change. The session would cruise through different technologies and also would re-evaluate the waste strategies. The session discusses the linkages between solid waste and climate change. Waste prevention and recycling, jointly referred to as the waste reduction, help us to better manage the solid waste we generate. Preventing waste and recycling also are the potent strategies for reducing greenhouse gases. Some of the strategies are reduction of emissions from energy consumption. Recycling too saves energy. That's because making goods from recycled materials typically requires less energy than making goods from the virgin material. And the payoff is when the energy demand decreases, fewer fossil fuels are burned and less carbon dioxide is emitted to the atmosphere. Reduction of emissions from incinerators would divert certain materials from incinerators through waste prevention, and recycling reduces greenhouse gas emissions to the atmosphere. Forests take large amount of carbon dioxide out of the atmosphere and store it in wood in a process called carbon sequestration. Waste prevention and recycling of paper products can leave more trees standing in the forest, continuing to absorb carbon dioxide from the atmosphere. And this increases the storage of carbon in trees. Waste prevention and recycling, including composting, diverts organic waste from landfills, reducing the methane released when these materials decompose would help in reducing methane emissions from the landfills. When less energy is consumed to extract, transport and process raw materials and to manufacture the products, when people reuse things or when products are made with less material, waste prevention becomes even more effective. The session further progresses to establishing linkages between waste management and the greenhouse gases. Some scenarios are discussed, such as felling of trees, extracting oil and the like would lead to increase of greenhouse gas emissions, whereas recycling and waste prevention leads to lowering of greenhouse gases. Similarly, factories where goods are manufactured leads to emission of the greenhouse gases. On the other hand, if the production is less or the products are recycled, this would lead to a lesser production of the GHGs. Burning the waste in incinerators are again a source of greenhouse gas. But if the waste is reduced, then less of the load will be on incinerators, thus leading to lesser emissions of the greenhouse gases. There is a pressing need to re-evaluate our wastes. The waste industry occupies a unique position as a potential reducer of the greenhouse gas emissions. As industries and countries worldwide struggle to address their carbon footprint, waste sector activities represent an opportunity for carbon reduction which is yet to be fully exploited. Waste offers a significant source of renewable energy. Incineration and other thermal processes for waste to energy such as landfill gas recovery and utilization and use of anaerobic digester. Biogas can also play an important role in reducing fossil fuel consumption and greenhouse gas emission. The section on greenhouse gas emission enablers will briefly present some of the processes and technologies currently available. Conceptual approaches and integrated technology systems are also mentioned as they are important in deciding on-site specific and relevant combinations for waste management systems. Waste prevention is an issue of high priority in the waste management, and it is likely that a number of new approaches will develop worldwide over the coming decades. The subject will therefore be examined in greater detail. There are three key components to a unified waste management strategy, which would enable the waste sector to become a global net greenhouse gas emission saver. First, being to establish integrated waste management system. Second, being introduction of waste technologies with lower energy consumption and reuse of processed residuals. And the third being energy recovery. The collection and transportation of waste is also a very important sector of waste generation. Waste collection necessarily involves the use of vehicles and consumption of fuel. There are wide variations in both fuel types and consumption levels. Hence, the amount of fuel used for each collected ton of waste can vary according to the collection system used. The session then moves to the discussion of technologies of waste disposal. The technologies discussed are recycling, composting and anaerobic digestion, which constitute the biological treatment, incineration and landfilling. Each technology discusses about the greenhouse gas emission sources and the ways to reduce them. Many industries use recycled material to avoid the greenhouse gas emissions associated with extraction, transportation and to the production site, and energy use involved in producing new products from virgin material. Material separation for recycling may take place at a source, for example in households, or after collection in centralized facilities designed according to the material recovery priorities. Studies which have evaluated greenhouse gas emissions from composting activities have shown that emissions are affected by technology and operational practices employed, as well as by the waste types received. In addition to the emissions related to electricity consumption, both methane and nitrous oxide have been detected in varying levels. Incineration of waste refers to the controlled combustion of solid waste in modern furnaces equipped with up-to-date pollution controls. It is an effective method of converting waste into energy while reducing volumes of residual waste to be sent for the disposal. Where it is technically and economically feasible, incineration processes can provide very high energy efficiency and associated greenhouse gas emission reductions from waste management by using the power generated for electricity and heat and thereby reducing the consumption of fossil fuels. The greenhouse gas emissions involved in the process include the consumption of electricity by blowers, electrostatic precipitators, and the fuels by startup fuels, transport, etc. And the emissions of carbon dioxide originating from fossil carbon in the received waste, ancillary fossil fuels, and the recovery of heat and electricity must all be taken into account. Landfilling refers to the disposal sites where waste is placed in line sections and degraded while producing carbon dioxide and methane, a potent greenhouse gas. Landfill methane emissions are the largest source of global GHG emissions from the waste sector activities. Many countries require all operating landfills excepting organic waste to be equipped with active gas and leachate collection and treatment systems. Landfill processes can be stimulated and controlled in order to simulate a biogas reactor, significantly shortening the period over which gas and leachates are produced. The session then puts forward the recommendations. The potential for waste-related greenhouse gas emission reduction should be exploited globally in order to ensure that waste management becomes a net greenhouse gas emission reducer. Cities, regions and countries should systematically assess present emissions from waste management and develop schemes to become net greenhouse gas emission reducers. The waste industry should improve the transfer of knowledge, skills and technology from developed to the developing countries. The waste sector should continue making use of proven technologies and experiences as well as facilitate research and development programs to seek even more friendly climate solutions.